Okay, so today we're going to work on final review.
Hold on.
Final review unit 4. Okay, unit 4 was mostly about parabolas. However, parabolas have also a lot to do with factoring and multiplying. Okay, so for unit 4, for example number 1, first thing I would like you to do is find the volume. Okay, find the volume. I am going to draw you a cube. If you can't draw it perfectly, don't worry about it, okay? Find the volume of a cube. If this side is x plus 1, this is 2x plus 5, and the depth is x minus 3. Find the volume. Now, if this was a real-life situation, what would you say this cube is missing? Anyone have any idea? What's missing from the way I wrote this? What should it technically have? If you're finding the volume of something, it's real, right? How do we measure things? Length times width times height, okay? But it's missing a unit of measurement. Technically, there should be inches or units, something like that, okay? This technically is not even written right because there's no unit of measurement, but I think you'll be okay. Okay, so what we're going to do, let's see, is what is the formula for volume? You guys should all know this one from like, I don't know, 3rd grade. Length times width times height. Now, is that the same thing as height times length times width? Is that the same thing?
Yeah.
So my point here is it really doesn't matter what order you multiply them in. It's just that you multiply them all together. Okay, so it doesn't really matter which one is which. I just want you to multiply them together. So we're really going to multiply x plus 1 times 2x plus 5 times x minus 3. Now, does not particularly matter what order you multiply these in. That's what I just said. But I would go left to right. It's just a little bit easier. So I would multiply the first two together. And those first two, you can use the boxes if you really feel like you need to. I'm going to use FOIL. And remember, FOIL just stands for first, outside, inside, last. It's nothing special. It's just an order for you to remember to multiply all the parts together. So first times first would give you 2x squared. Outsides would be plus 5x. Insides would be plus 2x. Last would be plus 5. And that still needs to be multiplied by x minus 3. Can anyone tell me, because this is a really common mistake, what is wrong with the way I've written this problem now? I do need to combine like terms. So great, if I rewrite this, 2x squared plus 7x plus 5 times x minus 3. What's wrong with the way I've written that? X minus 3 shouldn't necessarily be in front. But am I just multiplying the 5 or am I multiplying everything? I didn't write the parentheses. If you forget the parentheses, the tendency is for people to just distribute the 5, okay? It matters. Silly little things like that I know you guys think, or you don't show your work or something like that. I know you think that, oh, it doesn't matter. It's no big deal, right? Well, it's a totally wrong answer. So it kind of does matter. Okay, here you can either use the boxes or I prefer using old school method. So I'm just going to line up the smaller one, the binomial, underneath. Okay, you don't have to even rewrite it. I'm just going to write it underneath, write the smaller one under. Then multiply. So negative 3 times positive 5 gives you a negative 15. Negative 3 times 7x is minus 21x. Negative 3 times 2x squared gives you a negative 6x squared. Leave a space or put a plus 0. X times 5 gives you plus 5x. X times 7x squared. If you are not writing this down, you are making a mistake. You need to write this down. X times 2x squared. And the mistake is not making me mad. Although that is a mistake as well. Tanner. Then everything is lined up perfectly. Okay? Lined up in like terms. So 2x cubed is just 2x cubed. Negative 6, positive 7 gives you plus 1x squared. If you write the 1 in front, that's fine, but you don't have to. Negative 21, positive 5 gives you minus 16x, and negative 15 plus 0 is minus 15. Now, should I factor this? No. Should I set it equal to 0 and try to solve? No. You're done. Okay? A lot of people are making mistakes where they're doing more than it's actually asking you to do. You're done. Okay? Just be done. Don't worry about doing more. Okay? That's your answer. Now, technically, like I was talking about earlier, this is volume, so it should be units cubed. I'm not super concerned about that, so I'm not going to worry about it. Okay? For number 2, if I tell you the volume of a rectangular solid, the volume of a rectangular solid, basically just a fancy way of saying a box, okay? The volume of that is 4x cubed plus 19x squared plus 12x cubic units. We're going to tell you if the height is x units, I want you to find the possible length and width. The volume of a rectangular solid is 4x cubed plus 19x squared plus 12x cubic units. If the height is, is x units, forgot the x, sorry. The height is x units, find the possible length and width. So we just went over volume. Volume is equal to length times width times height. So we're just going to plug things in here. Okay, the volume they gave me, 4x cubed plus 19x squared plus 12x, is equal to length times width times what? What is height? Times x. So before I can find length and width, what do I have to do? Get rid of the x. How do I bring that x over? How is it attached right now? By add, subtract, multiply, or divide? By multiplication. How do you undo multiplication? Divide. So we're going to divide everything by x. Okay, divide it all by x. Can I simply reduce the x with the 12x? Can you just reduce that? No. Can I just reduce the x with the x cubed? No. You have to basically take out a GCF of x. Okay, if I took out an x from every single portion, what would be left behind? 4x squared. That's a 4, not a 14. Plus what? 19x plus what? 12. And that would equal your length times width. Now, if I was asking for the possible lengths and widths, am I done? No. What do I basically have to do here? How do I find the possible length times widths? Factor it. Okay? You have to factor. You can use over/under. However, if you plan on taking any math class beyond this class, they will not use over/under. You have to use guess and check. Okay? It's not mandatory, but if you're still stuck on over/under, they will roll you over. Okay? Guess and check is the preferred method of solving this. Right? If you do not want to use it, that's fine. But I'm still going to show you how, just in case. Okay? To do guess and check. If you guys want to do over/under, that's fine. Do it. Okay, but I'm going to show you how to do guess and check. Guess and check, you write out the first factors. So 4 would be either 1 and 4 or 2 and 2. 12 can come from either 1 and 12, 2 and 6, or 3 and 4. Then you are literally going to guess at what the front values would be and guess at what the back values will be. What are your signs going to be? You know the signs. Both plus, both minus, or one of each? Both plus, right? So at least that part's easy-ish. Now, you get to guess. Do we want to pick 1 and 4 or 2 and 2? Why would you want to pick 1 and 4? Because you should. but do you know why? Don't know why?
Because it makes the first number.
2 and 2 also make 4. That's why we wrote them down, okay? I'm going to show you something. I don't want you to write this part down. If I did 2x and 2x, then I picked any of these. Any of them, doesn't matter. Let's say I picked 3 and 4. Is there any possible way that that could work? And why? Why could it not work? Has to do with this parentheses. If I had 2x plus 4, what does that tell you me I should have had at the beginning? A GCF. Did I have a GCF at the beginning? No. So there's no way you could ever use 2 and 2. Because no matter what, 2 in here is always going to be matched up with an even number, right? It's not possible. So there's no way you could ever have 2 and 2 automatically. Are there any other options that you can completely cancel out because of the same reason? 2 and 6, exactly. Okay? The back ones, there's no way you could ever have 2 and 6 because the same thing could happen. Okay? You could never have 2 and 6 because those would have produced a GCF. So again, you can reduce the number of options. Okay? I'm trying to show you guys that you can do things a little bit easier. At least you can eliminate some options, okay? So at least I eliminated those options. Now I know that I have to use 1 and 4, so 1x and 4x. And then I either choose 1 and 12 or 3 and 4. If I choose 3 and 4, could I ever do it this way? No, why? Because of GCF. So you can eliminate some options, okay? Would you like to use 3 and 4 or 1 and 12? 3 and 4? Well, obviously I can't put the 4 here, so by default it would go here. The 3 would go here. The guessing part of guess and check is really just checking the middle. Okay? Multiply these together. 4 times 4x gives you 16x. 1x times 3 gives you 3x. Do those add together to give you the middle that I need? Yeah. That's your answer. Now, I totally understand that's a lot more difficult than over under. But this is actually the correct way to do it, okay? If you use over under, there's a lot of times that people can forget some of the steps, and then it doesn't work if you don't know the steps. This way, guess and check will always work because there's not any tricks to it, okay? It's just checking. Questions on how I did that? So, if I asked you, like on your final, there's going to be one similar to this that says, which of the following could represent the width? Would you expect that both of these answers would be there? No, just one. So you're going to have to identify that, oh, well, that could be the width. Okay, so you actually have to find both answers even though one will be there. Okay. Next thing we're going to do is we're going to look at parabolas. Okay. Most of this unit was about parabolas. Does anyone remember what are the 2 different formats that you saw parabola equations written in? There's 2 different forms. Remember what they're called at all? Standard form. There's always going to be a standard form. Does anyone know what standard form, what the equation for standard form was? It was a y equals, it's basically the one that we use all the time. ax squared plus or minus bx plus or minus c. This is a quadratic equation. It's not the quadratic formula. Quadratic formula is the one that has the song. Quadratic equation is anytime you have something squared. Okay? What's the other form that we used? It's called descriptive form. Okay, descriptive form. And that one is y equals a times x minus h squared plus k. So we had standard form and descriptive form. Does anyone remember what are the important parts of a parabola? What are the parts we need to graph a parabola or to sketch a parabola? There's 2 main parts. What was it? Anyone know? LOS stand for anything to anybody?
Oh.
Line of symmetry. Okay. First thing we found.
No, I'm kidding.
No, it's LOS. No. LOS is the line of symmetry. And does anyone remember what's the equation or the formula to find line of symmetry? Always an x equals equation. X equals what? negative b over 2a. At least you remembered a little bit of it, okay? What's the other portion that we almost always had to find in an equation? We found the line of symmetry, and then what? The vertex, okay? Vertex, you use x from line of symmetry, plug in to find y. Okay, so you use the x from the line of symmetry, plug in to find the y. The vertex is a what? Is it a line? Is it a parabola? Is it a point? What is it? Vertex is a what? It's a point. Okay, so that means it should be written in point form. It should be written as x comma y. That's the form that you should be writing your answer in. Now, how about descriptive form? And you remember, how do you find line of symmetry for descriptive form? Still an x equals equation, and how do you find line of symmetry? Change the sign. Okay, an x equals, we just change the sign of what's in the parentheses. So line of symmetry is the changed sign of whatever's from the parentheses. And remember, how do we find vertex? Change the sign, keep the sign, exactly. Okay, it's going to be a point, comes from changing and keeping. Change, comma, keep. And we're talking about the signs. Change the sign, keep the sign. So that's the overview. Now, if I asked you, for example number 3, and this is going to be a parabola equation, if I asked you to state the x-intercepts, state the x-intercepts of the equation 6x squared minus x minus 2. State the x-intercepts of that equation. Anyone remember, how do I find x-intercepts? What does it look like this equation is? It looks like, what would you have to do to this? Factor, right. That's all you do to find x-intercepts. Okay, x-intercepts you factor. You basically make this whole thing equal to 0 and then factor and solve. What's the first thing you should look for in factoring? GCF. Is there GCF? Not really. Okay, so you're going to have to factor. You can use over under if you want to, but eventually you're probably going to have to learn guess and check. So I'm going to show you guess and check. Okay, the front number could either be 1 and 6 or 2 and 3. To get 2, it has to be 1 and 2. So there's not that many options that you can even really try here. Okay, do we know what the signs are here? One of each, right? Do I know which one goes where? So you don't want to put those in yet. Okay, if it's plus and minus, you always do it at the end. But I do know that I'm going to have a 1 and a 2 at the end of my parentheses. Which would you like to choose for the front? 1 and 6 or 2 and 3? 2 and 3? Okay. Do we know which one would have to go here and which one would have to go here? Could I put the 3 in here with the 2? Yeah. Could I put the 2 in there? No, because it would have had a GCF. So by default, it would have to be 3x and 2x. Now, before you can put in the signs, you do have to check this. Okay? Oh, I just said by default I couldn't do it this way, and I wrote it backwards. Sorry. So yes, by default, this has to be the 3. This has to be the 2. Now, check it. So check it, I mean check the middle. So 1 times 3 gives you 3x. Outsides, 2 times 2 gives you 4x. If I know I have to have 1 plus 1 minus, can I get a negative 1x from a 3 and a 4? Yes. What would your signs have to be? 3 is positive or negative? Positive. Negative would have to be with the 4. And then you just follow this across. So this one gets the plus. This one, follow your line, gets the minus. Now, did I actually find the x-intercepts? No. How do I find the x-intercepts? Set them equal to 0, right. So 2x plus 1 equals 0. You're going to split them up, set them equal to 0. And 3x minus 2 equals 0. Okay, do inverse operation, so subtract the 1. That gives you a 2x equals negative 1. If you divide through, x is negative 1/2. This one, same thing, additive inverse would give you 3x equals a positive 2. Divide both sides by 3, x equals 2/3. Do you think that those are actually the answers? Are these the two x-intercepts? Why? You can't have more than one x-intercept because this is a parabola. So parabola could go through the x-axis twice if it was like that. Okay, it can have more than one. You can't have more than one y-intercept, but a parabola you can't have more than one x. What is wrong with these? Not necessarily the numbers, but the form. Our x-intercepts, what are they? Are they a line? Are they a point? Are they a shape? They're a what? A point. Is this a point? X equals negative 1/2, is that a point? No, it's a line right now. So technically, to be correct, you have to write that as a point. How would you write that as a point? Negative 1/2, comma what? 0. Okay, negative 1/2, comma 0. And you know that because if this went through at negative 1/2 and a positive 2/3, the y value there is 0. Over 1/2, up 0. This one, over 2/3, up 0. So this is where I was telling you guys earlier, I wasn't that picky on your tests with this. Okay, I didn't really emphasize it because it didn't seem like it was a big deal. It's not a big deal because I know what you mean if you write this. But if you're just taking a test on a computer or something, the computer doesn't know that, well, you meant to put in the 0 and make it in parentheses. It doesn't know that. So I would hate for you to get the right values and then the format be wrong and you get things wrong based on something that's technical, okay? So that's why I'm being kind of picky about these. Okay, next thing I'd like you to do, I only have 2 more. For example, number 4, I would like you to give the vertex and state whether it is a maximum or a minimum. State whether it is a maximum or minimum. Give the vertex and state whether it is a maximum or a minimum. And there's actually 2 parts to this one. Okay, the first equation is y equals x squared plus 8x plus 1. The second equation is y equals negative 3 times x plus 7 quantity squared. Give the vertex and state whether it is a maximum or a minimum. Now, based on just the equation, we should actually be able to tell you if something is going to be a maximum or a minimum. Because what do you know just based on the front number here? What do you know about the direction this opens in? It opens up. So if it's not a perfect graph and you had a parabola that opens up, just say it was like that. Does this have a maximum or a minimum value? A minimum. So automatically, I know this is going to be a minimum because it opens up. Now, how do I find that vertex value? What form is this in? Standard form or descriptive? Standard. How do I find the vertex value of a standard form parabola? Start with x equals negative b over 2a. The x equals part is important. So if I plug this in, what's the negative b value? Negative what? 8 over 2 times what's the a value? 1. So negative 8 over 2 gives you an x value of what? Negative 4. Now, how do I find the y value for the vertex? Plug it back in. So take this x, plug into wherever x is. So y would equal negative 4 squared plus 8 times negative 4 plus 1, and work it out. Negative 4 squared is 16, minus 8 times 4 is 32, plus 1, what's 16 minus 32? Negative 16 plus 1 gives you a value of what? Negative 15. So what is the vertex of this parabola? -4, -15. It is a point. Okay? If you don't write it in a point format, it will be wrong. This is the vertex. And did we say it was a maximum or a minimum? A minimum. Now, is the maximum or minimum referring to, if I asked you for the value of the maximum or minimum, is that referring to the x value or the y value? Do you know? Like if you labeled this and said it was at -4, -15, and I know it's on the wrong side, is that the lowest value that the x will ever get? No, because it's going to keep going, right? The x values go forever. That's where we talked about domain and range. So the minimum value is actually the y value. Okay, I'm not asking for the value here, but if I did, you could find it. How about this one? This one's a lot easier, okay? First things first, is it going to have a maximum or a minimum? And how do you know? You know that this faces what direction? Opens in what direction? Opens down. You know that because of this negative value up front. So is this going to have a maximum or a minimum? A maximum value. This is going to be the highest it ever gets. So it has a maximum. And what is its vertex? How do we find the vertex of this parabola? Change it, keep it. What am I keeping here? A plus 0. So the vertex would be where? -7, 0. Change it, keep it. Okay, so it's a lot easier when these are written in descriptive form. We like it better. Questions on how I did that? I have one more. I know these are long notes, but I want to make sure that you guys are pretty clear on this, okay? Last one, example 5. I want to know, how does the 3 change the graph? How does the 3 change the graph of y equals x plus 3 squared plus 1 from the original graph? How does the 3 change the graph of y equals x plus 3 quantity squared, so in parentheses squared, plus 1 from the original graph of y equals x squared? So if I'm moving something, if I'm moving a whole graph, what's the only point that I'm really concerned about moving? The what? What's the point that you make your starting point from? What's it called? The vertex. So I don't really care about graphing the whole thing. I really just want to graph the vertex. So if I start here, what's my vertex? What's the vertex of this parabola? 0, 0. Right? So if I start my parabola, if it starts off at 0, 0, and it moves, it translates, kind of migrates to be this parabola. What's the vertex of this parabola? -3, 1. So it would move over 3 spaces and up 1. Now, it really doesn't matter that this would open up. Okay, it has a minimum. But what did that 3 do? What direction did it move it? Left. How many spaces? 3 units. So the actual answer here is 3 units left. Okay, so you have to understand how to translate from one parabola equation to the next. Homework for this is going to be the Unit 4 review homework in your packet. You only have to do the odds. Of course, I will collect it on Monday. Thank you.